till now we have seen the first synthetic curve, which was a cubic spline curve. Okay? So which was designed on the basis of two input points and the tangents which were drawn from those respective points. We can call them as even the endpoints. Okay? The second one is the Bezier curve. So what exactly Bezier curve is and how it is different from the first synthetic curve, that is the cubic Hermite cubic spline curve. Okay? So by can say default, it is a type of a spline curve which is again based on the set of the data points. Okay? The input point as well as the input points, that is the start point and end point, these can be considered as the two endpoints. Okay? This curve, it provides a better flexibility, okay, in changing the shape. Okay, so we can say that the Bezier curve is more flexible as compared to the Hermite cubic spline, okay, because it's not very convenient to change the shape in case of the Hermite cubic spline curve. Okay. So it was first developed by the you can say uh, P. Bezier, okay, at an auto company, okay, which was used for the modeling of the car surfaces. Okay. Just to demonstrate how it exactly looks like or how it appears to be. These are the input points, P1, P2 and P3. Okay. And this is the curve, the direction of the curve. So unlike the Hermite cubic spline curve, the tangents are not involved in this case. Rather, it is defined on the input points. These are also known as the control points. So P0 is the start point and P3 is the end point with the value of parameter u ranging from u equal to 0 to u equal to 1. That is, u lies in between 0 to 1. Okay. Thus, it tends to form a characteristic polygon. Points P0 and P3, they are termed as the anchor points. Okay. And P1 and P2, these are the control points. Okay. This curve, it uses approximation, okay, and it does not necessarily pass through all the points, okay, but these are more or less influenced by the control points. Okay. So it is an approximated curve. The shape of this curve is again defined or it is controlled by its defining points. So as the first order differentials were used in the curve development in case of the cubic spline curves, Bezier curve does not use the first order differentials. Okay? So this gives rather more prediction about the curve for the designer. That is, by merely looking at the control points, he can define the degree of the curve. Okay? So the order of the curve is dependent on the number of the control points. Okay? So order of curve is defined by or it is determined by the number of control points. To define the Bezier curve, the data points for the control points, they have to be defined. Okay. These points, they form the Bezier characteristic polygon. Okay. The major characteristics of the Bezier curve, they are the curve passes through the start and end points of the characteristic polygon. This one is the start point and this one is the end point. So it passes through the start and end point. Okay. Whereas the other control points or the vertices, we can say, they define the order or derivatives and shape of the curve. Okay. So the control points, they define the order as well as the shape of curve. Okay. So as the order of defining the control point changes, okay, the shape of curve will also change. Okay. So this can be illustrated by the figure. So let us again define 4 points, control points, as P naught, then P1, P2 and P3. Okay, and the curve that passes through the start and end points, that is P0 and P3 and P0, P1. If this is the sequence, P0, P1, P2 and P3. Okay. So similarly, if the sequence is changed, okay, the shape of the curve, it also does change. So P0, so I'm replacing P2 by P1 and P1 by P2, and this one is P3. Okay. So the nature or the shape of the curve will be changed now. Okay. Since the sequence has been changed. Okay. So the same data points, but the different order, okay, is seen in both the curves. Okay. So this curve can be generated if the sequence of the points is changed from, let's say, P0, P1, P2, P3, or in reverse order as again P3, P2, P1 and P0. Okay. So the Bezier curve is always rather tangent to the first and the last control points. Okay. And it tends to follow the shape of a polygon. Okay. So again, let us see some of the shapes that can be defined by a curve, these Bezier curves. So P naught, P1, P2 and P3. These are the 4 control points. Okay, this is the nature of the curve. Tangent at first point, sequence P0, P1, P2 and P3. And this is the direction of the curve. Okay. Or if the sequence or the direction is changed, so P0, P3, P1 and P2. Okay. So it has to be tangent at the first as well as about the end point. Okay, and this will be the direction, that is from P0 towards P3. Okay. And obviously the value of u will range in between 0 to 1. That is, it is a parametric curve. This Bezier curve is based on the Bernstein's polynomials, which defines the polynomial coefficient. Is defined as C of ni, where n defines the degree of polynomial, where n is the degree of polynomial, okay, and the value of I, it characterizes the control point. Okay. I, it characterizes the control point. So this binomial is defined as C of ni is equal to n factorial upon I factorial into n minus 1 factorial. Okay. So let's apply the boundary conditions to this polynomial coefficient, that is at I is equal to 0, that is about the start point. Okay. C of n0 will be equal to n factorial upon I, that is 0 factorial upon n minus I, that is n minus 0 factorial. So it will be again n factorial upon n factorial. So the 1 upon 0 factorial, or the answer will be equal to 1. Then at I equal to 1, that is the end point of this curve, Cn, n it will be in this case. So this will be equal to n factorial upon n factorial into n minus n factorial, that is again it gives 1. So this Bezier curve, this can be defined in terms of the parameter u as p of I, okay, into the polynomial coefficient into u of I to 1 minus u raised to n minus I. Okay. So this same equation in terms of the control points, it can be written as p of u is equal to p naught, that is the value of I, initial value of I, that is I equal to 0, c n of 0 into u raised to 0 into 1 minus u into n minus 0 plus p1 c of n1 into u raised to 1 to 1 minus u into n minus 1 plus p2 into c of n2 u square 1 minus u into n minus 2 plus up to the nth term, that is p of n into c of nn into u raised to n into 1 minus u into n minus n, where u ranges from 0 to 1. So substituting the values of the c n naught and c n1 in this polynomial equation, so this equation will be, after substituting the values of c n naught and c n1, okay. So I have p naught into the value of c n naught was equal to 1, so multiplied by 1 into u raised to 0 is again 1 into 1 minus u raised to n plus p1 into cn1 is also equal to 1. Oh, sorry, we found out the value of cn and not 1. So cn1 will be as it is into u raised to 1 minus u into n minus 1 plus p2 into c of n2, then u square into 1 minus u raised to n minus 2 plus up to pn. Okay. So the value of cnn was 1, so replace it by 1, multiplied by 1 into u raised to n into 1 minus u raised to 0. Okay. So the terms will be, this is the general equation, so p of u will be equal to p naught into 1 minus u raised to n plus p1 into c of n1 into u into 1 minus u raised to n minus 1 plus p2 into c of n2, that is I is equal to 2 into u square 1 minus u raised to n minus 2 plus pn into u raised to n. Okay. So in general, the most of the CAD systems, they allow the input of the four control points. Okay? So amongst which the first or the start point will be equal to P naught. Okay? So four control points in which the first point P naught will be the start point and P3 will be the end point, or we can say Pn, because this curve will extend from P naught up to the nth value. So that will be equal to P3, that will be the end point of this curve. Okay. So thus the value of n will be equal to 3. Okay. And the binomial terms, they can be evaluated as the C of n I, that is equal to C of 3 into I, that is equal to n factorial upon I factorial into n minus I factorial. Okay. So that is equal to 6 upon I factorial into n minus of I factorial. Okay. So now we'll find out the values, the corresponding values for these binomial coefficients. So for C of the we can say value of n, okay, that is equal to 3, and the value of I is equal to 0. So it will be 3 factorial upon 0 factorial into 3 minus 0 factorial, that is equal to 1. Then the second polynomial coefficient will be C of 3 1, that is equal to 3 factorial upon 1 factorial into 3 minus 1 factorial, that is equal to 6 upon 3 minus 1, 2 factorial, that is 2, so that is equal to 3. Then again the second coefficient with I is equal to 2, so 3 factorial upon 2 factorial into 3 minus 2 factorial, so that is equal to 6 upon 2 factorial into 1 factorial, that is 2, so the value will be 3. And C, the coefficient, binomial coefficient for I equal to 3 and n is equal to 3, so it is going to be 3 factorial upon I factorial into n minus I factorial. Okay, so again this will be cancelled, and the value will be 1 upon 0 factorial is equal to 1, so it will be equal to 1. So I'll substitute now these binomial coefficients in the general equation. It is P of u is equal to P naught into 1 minus u raised to n. So now n is equal to 3. So 1 minus u raised to 3 plus P1 into C of n1, that is equal to 3, multiplied by u into 1 minus u raised to n minus 1, that is 3 minus 2, that is square of the term, plus P2 into C of n2, that is also equal to 3, multiplied by u square into 1 minus u raised to n minus 2. So that is n minus 2, that will be equal to 1 again, and plus Pn raised to un. So that will be equal to P3 into u cube. Okay. So u ranges from 0 to 1. So P of u will be equal to P naught into 1 minus u cube plus 3P1 into u into 1 minus u square plus thrice of P2 into u square into 1 minus u plus P3 into u cube, where u ranges from 0 to 1. Okay. So this is the generalized equation, and the characteristics of the Bezier curve. This is the generalized equation. characteristics is it never uses the tangent vector for controlling its shape. Tangent vector is never used to control the shape. So if you remember that we had discussed during the Hermite cubic spline curve, so if this was the curve, these are the two tangent vectors. So just to change the direction, okay, if the tangent vector, direction of the tangent vector was changed, so this angular orientation with respect to the curve will remain constant, but the nature or the shape of the curve got changed. Okay. So the shape of the Bezier curve, okay, is controlled by a set of data points that are nothing but the control points, which gives the better flexibility in controlling its shape. Okay. Controlled or controlled by the points so as to get the better flexibility. Okay. Then curve with n plus 1 data points is defined by the polynomial n degree, that is Howard polynomial, okay, which defines the high order continuity of the curve, and the degree of the curve, okay, that is given by n minus 1. So if n are the number of the control points, then the degree of the curve is equal to n minus 1. Okay. So this is about the Bezier curve, okay, which is again a type of a spline curve. It is an approximated one, okay, and it doesn't depend on the tangent vectors, but it is governed by the control points.